So for this lecture, we're going to be talking about inferential statistics and hypothesis testing. So we'll start out spending a little bit of time explaining inferential statistics, and then we'll spend the bulk of our time talking about hypothesis testing and the four steps in hypothesis testing. Then we'll wrap up talking about type 1 and type 2 errors. So earlier this semester, we talked about the two branches of statistics. We talked about descriptive statistics, and we spent time talking about central tendency and about variability. Today, we're going to be talking about the second branch, which is inferential statistics. And this is the type of statistics where we're trying to understand whether or not the results from a study which we got from a sample can be generalized to a broader population. And we want to understand if the results that we got for our one study reflects the results that we would have gotten if we had run the study multiple times with different samples. So if we go back to our lecture on sampling, we talked about we have a broad population and we want to get a smaller sample from that population to collect data and get information from. What inferential statistics is doing is taking the information from that sample and is trying to generalize back to the population. So the information we got from that sample, can we now generalize it back to the broader population from which we got that sample? So hypothesis testing is the process by which we determine whether or not the data that we collected from a sample either supports or refutes our hypothesis. And hypothesis testing is based on probability theory, which won't get into for this class, but it's all based upon probabilities, the likelihood or the probability of getting one outcome versus another outcome. The researcher is trying to assess the likelihood of getting a particular result if the null were true. And I'll talk about the null hypothesis in a minute, but we're always basing our results from our sample to what we would expect if the null was true. And I want to give you an analogy to hopefully help you understand how hypothesis testing works. So I'm going to use a legal system. So in a legal system, a person is charged with a crime, and then the person is presumed to be innocent initially. Then the prosecutor and the police try to collect evidence to show that this person is actually guilty. And then the jury or the judge only convicts when the evidence is beyond a reasonable doubt. So it has to be very compelling evidence that this person is actually guilty. In the absence of that, the person is considered to be innocent. So in many ways, hypothesis testing is very similar to the legal system. So as I said at the beginning, in the legal system, a person is accused of a crime. For hypothesis testing, the researcher makes an hypothesis. So you can think of it as accusing someone of a crime. So you're hypothesizing that this particular independent variable is going to have an effect on the dependent variable. Now, just like in the presumption of innocence, the default assumption is that the hypothesis is incorrect, so that there is no effect of the independent variable on the dependent variable. So the default assumption is what's called the null hypothesis. Null meaning that there's no effect. And we'll talk about that in a second. And then the researcher goes out and tries to collect data to provide evidence in support of his hypothesis. So this is analogous to a prosecutor and the police trying to find evidence to show that this person is guilty, right? And then the researcher only rejects the null hypothesis if the results are highly unlikely. So if it's beyond a reasonable doubt in a legal sense, it's like in the research sense, it's beyond a reasonable doubt that you would get this particular set of results if the null were true. And therefore, we're going to reject the null hypothesis and conclude that the data supports what we're calling the alternative hypothesis. So we're going to have an example as we're going to be kind of explaining some of these concepts. So suppose I told you that I have developed this pill that is going to or can improve people's cognitive functioning, and I have the pill, but I need some financial backing, so I'm coming to you to see if you want to invest $100,000 in my startup company. And what we would do is we would split the profits 50-50 and get rich. Now, assuming that you are independently wealthy and you have that kind of money to throw around, I'm assuming that you would at least want to have some evidence that my pill actually worked. So, just go with a very simple way of testing whether or not this pill works. So, what you decide to do is you want to now compare the IQ of people who take my pill to the average IQ of the American population. So, if you know anything about standardized tests, IQ tests, they're standardized so that the mean is 100 with a standard deviation of 15. So what you do is you get a sample of 50 people. You give each of those people one pill a day for 3 months, and what you want to now see is the average IQ for this sample of 50 significantly different than what you would expect from the population, which would be 100. So now what I want you to do is I want you to pause the video and I want you to think about what are the conceptual independent and dependent variables, and then what are the operational independent and dependent variables. So when you're trying to understand this, what I want you to do is I want you to think about that on a conceptual level, what you're trying to do is you're trying to see what would happen if you had given everybody in the population um, the pill once a day for 3 months, what their IQ would be after receiving the pill. The problem is you don't have access to everybody in the population, so what you do is you get a sample of 50 people, right? And hopefully you get a representative sample of 50. And what you want to see is if you gave that sample of 50 the pill, what their IQ would be. And what you're going to conclude is, based upon that sample, you're going to infer what would have happened if everybody in the population would have gotten that pill. So you're trying to infer, based upon your sample of 50, what would have happened if you had given everybody in the population that pill. So on a conceptual level, we want to understand if there's a difference between the population's IQ before the pill and after the pill. But in reality, we don't have the ability to do that. So what we're trying to do is we're trying to see if our sample of 50 differs from the population, what we know to be the population mean of 100. So if our sample of 50 has a mean that's significantly higher than 100, then we can now infer that if we'd given the pill to everybody in the population, that the population's mean would have been significantly higher than 100 as well. But again, we're actually making comparisons between the mean population of 100 and the mean of our sample of 50. Okay, so now that we've kind of discussed that, let's go through the 4 steps of hypothesis testing. This gets a little bit tricky, so just hang in there, and it'll hopefully make sense by the time we get to the end. So definitely remember these steps. So the first thing you want to do is you want to state your hypotheses. You want to identify the null hypothesis, which you don't typically state in a paper, but you kind of need to know what it is. And then what you actually state is the alternative hypothesis. So I want you to be comfortable understanding what those hypotheses are. Then the next thing you do is you set the criterion for deciding whether you should accept or reject the null hypothesis. So how far does your sample mean have to be from the expected mean before you can reject the null hypothesis? Then you go out and you collect data to see if the study provides evidence that your sample mean is different than the expected mean. And then in the final step, you make a decision about whether to reject or accept the null hypothesis based upon the criteria you set in step 2 of the process. So let's go through all these steps. They're all a little bit complicated. Well, the first one's pretty easy, but after that it gets a little bit trickier. So the first step is to state your hypotheses, right? And we talked about before, as an hypothesis is a statement regarding the relationship between 2 or more variables. And that a good hypothesis should be declarative. So it's not asking a question, it's making a statement. It should state what you're expecting to find. So if one variable causes changes in another, or one variable is related to another, you want to be very specific about that. then it also has to be testable, right? So it has to be able to be falsified. So the null hypothesis, as I've kind of alluded to already, basically says that in the population that there's no change, no relationship, no effect. So if we're talking about an experiment that you basically are saying that the mean of your sample is basically the same as the mean for what you would expect in the population. If it's a correlation, you're saying that there's no relationship between the two variables, right? And again, this is the default assumption. So this is like in the legal system, the defendant is presumed to be innocent. And typically, the researcher's goal is to be able to reject the null hypothesis because he or she wants to be able to show that there is some type of change or relationship or an effect. And that change, relationship, effect is stated in the alternative hypothesis. So this is where you're saying that there's going to be some type of relationship if you're talking about correlations or an effect if you're talking about an experiment. So again, this is analogous to the prosecutor making a claim that the defendant is guilty, right? And just like a prosecutor, the researcher has to now go out and collect data to provide evidence that the null hypothesis is not accurate, or in a legal system that the defendant is not innocent. All right, so what is the null hypothesis for this study? What's the alternative hypothesis? So take a moment, pause the video, see if you can write down what those are. So the null hypothesis for this particular example is that the mean for everybody who took the pills, so the sample took the pills, is the same as the mean for the population. And again, in this particular example, IQ tests are standardized to be 100. So we're saying that the mean for our sample will be somewhat around 100. So it may not be exactly 100 because there'll be some measurement error involved, but it'll be relatively close to 100. So we're just going to put the mean for our sample essentially is the mean. The sample is equal to the mean for the population. The alternative, we're saying that those who take the pill will have higher IQ than those in the population, which would indicate that the pill actually improved their performance or improved their cognitive function.